Hi everybody, I'm moving on with probability and we're going to start talking about lesson 3, which is about conditional probabilities, and we're going to see a lot of two-way tables in this lesson. So we definitely have to define and know what a conditional probability is. It's just that the probability that one event happens given that another event has already definitely happened. So your notation for conditional probability looks like this. Okay, and more important, it's read as the probability of B given A. So, in other words, what is the probability that B is going to happen given that A has already happened? So, let's take a look at this first example. They're talking about a study of 52 graduating seniors are surveyed as their post-graduation plans, and they're sorted by gender. So they're asking first, what is the probability that a person is chosen at random? So it does say one student is chosen at random. The probability of picking a female student. So we do have totals here, and the total females are 22. So what is the probability of picking a female? 22 out of the total number of students there, which is 52. Right? Everybody sees that. And the next one, what is the probability of going to college? Well, there's 29 kids total that went to college out of your 52 altogether. What is the probability that you are female and you are going to college? So female and going to college, there's 13 of them. 13 females are going to college out of your 52. Now take a look at this next one. Probability of female or going to college. That's what we had learned yesterday's lesson. So remember to find the probability of female or college, right? That's going to be your probability of female plus your probability of going to college minus the probability of female and going to college. Okay, so let's talk about that. So this is what we're trying to find, the or. That's your or. The probability of female is 22 out of 52. Plus the probability going to college is 29 out of 52. Minus the overlap. How many people are female and going to college? That's 13 out of 52. Okay, so when you add 22 and 29, you have 51 minus 13. That's going to give you 38 out of 52. That would be your answer. So that was from yesterday's lesson. Okay, so in two-way tables, just take note of the way they write it. Okay, you could either see the probability of B given A. Now I want you to take note of something really important. The probability of B given A is the probability of A and B over the total of A. So notice this, the second one, the one that has to be given, is in the denominator. And now take a look at the next one. It says the probability of A given B, which means, notice now, B is in the denominator. And just know that they're not like, you can't reverse them and they be equal. Just because I say the probability of B given A doesn't mean that equals the probability of A given B. Okay, so that's just important for you to see. Okay, so now we're going to talk those examples, but with conditionals. Okay, so take a look at the next part. The next part, they're showing you what's the probability of female given you're going to college. Okay, so literally if I were going to write this, this means the probability of female given going to college. Okay, which means, understand, this should be in your denominator. Whatever that number is, it belongs in your denominator. So how many people are going to college? 29 people are going to college. Of those given 29 people going to college, how many were female? 13. Okay, so that's how you do that. So look at your next one. What's the probability of going to college given you're a female? So again, remember, there's your denominator. The given is female. How many people were female? 22. So how many people of those 22 are going to college? And that would be 13. Everybody see that? Next one says G, going to college given male. So once again, I'm going to focus on my given amount of male students, which is 30. Of those 30, how many were going to college? 16. And in letter H, it says, are females or males more likely to go to college based on this 2A table? So what I didn't do was take those like 13 out of 22 and 16 out of 22. And I think what I'll do is just figure out exactly the percentage. So if I do 13 out of 22, I get about 59%. And 16 out of 30 is obviously going to be a little more than 50%. So I have about 59% and 53%. Okay, so just do a little approximately. You could either say 0.59 or approximately 59%. Okay, here you could say approximately 0.53 or 53%. So answering that question, which males or females are more likely to go to college? Obviously females, I would say females, because it's a higher probability. Females are more likely because higher probability. I'm just going to say that. Okay. Let's try another one. See how this goes. Let's look at number 2. Okay, in number 2 it says a survey was taken to examine the relationship between hair color. So we're talking hair color and eye color. So if a person is picked at random, find the following. So you got black, blonde, red hair, blue, brown, green hair. They give you all the totals, which is really nice. So here they say, what is the probability that a person has blue eyes given they have black hair? So if I'm just going to write that for you, okay, that means the probability of blue given black, okay, which means what should be in the denominator? Black hair. So of the people that have black hair, 0.45, 45% of the people. Of those people, how many had blue eyes? 0.15. Okay, if I want to simplify, 0.15 is a third. That's a third. You could even say, I could squiggle and say 0.33 or 33%. Okay, I guess I could say 33%. We're having a crazy thunderstorm at the moment. Oh, God. Okay, so I love that. The probability that a person has blue eyes, so here comes a probability that a person has blue eyes. So once again, blue. But now given they have blonde hair. So here, remember, denominator is blonde hair. How many people had blonde hair? 0.35. So of those 0.35, how many had blue eyes? 0.20. Okay, if I go into the calculator and do 0. So I'll do that for us. If I do 0.2 divided by 0.35, I get about 0.57, so approximately 57%. So I'll say, I won't go equals, I'll be equivalent 0.57, about 57%. Okay? Okay, next one says the probability that a person has blue eyes, so we're sticking with the blue eyes, obviously now given they have red hair. Okay, so of the people that have red hair, Red hair is 0.20, 20%. And how many of those people have blue eyes? 0.05, 5%. So that is a quarter. Yeah, that would be 1/4. So that would be equal to 0.25, which is equal to 25%. Okay, so now they want to know which color is most likely to have blue eyes. That's easy. Blonde hair. And a blonde hair person is more likely to have blue eyes because the probability is greater than the others. As easy as that. That's how you're going to explain. I would say blonde hair person is more likely to have blue eyes because the probability is greater than the others. Okay, so in the next part, you once again just see, which we already know, your conditional probability formulas, if you will. The probability of B given A is the probability of A and B over the probability of A. Notice whatever's given is in the denominator, okay? And in this one, the probability of A given B, notice the probability of B is in the denominator. So these would be really important if you were taking the regents, like the formula from yesterday, your OR formula, and your conditional probability formula would have to be memorized. I mean, obviously, you don't need to memorize it for now, but it is really good for you guys to know these. All right, so let's do a couple more problems. Let's do a practice without two-way tables, which is kind of nice because you're just going to have to know that formula. So in the next part, it's just saying, talking about a guidance department. So the guidance department has reported that the senior class, 2.3% are members of the Key Club, which they're calling K. 8.6% are enrolled in AP Physics, and 1.9% are enrolled in both. So what is the probability of P given K? Okay, so this is what this means. The probability of P given K. Okay, well, what does that mean? According to my formula, I know that that means the probability of P and K, both, the probability of that you are in physics and the Key Club, divided by the probability that you are in the Key Club, because it was P given K. Remember that K is in the denominator. So you're not going to use your percentages. I think that would maybe be one little thing that kids would maybe get wrong in a question like this. But the probability of both, we were told, here's both. That's the probability of P and K. Now, you're not going to use 1.9%. You're going to convert 1.9% into a decimal, which is 0.019. And what's the probability that you are a member of the Key Club? 0.023. Okay, so I'm going to go into my calculator. I'm going to divide that. I'm going to do 0.019. Nope, I'm still on the other thing, sorry. I'm going to do 0.019 and divide it by 0.023. And I have, it says say to round to the nearest 1/10 of a percent. Okay, so nearest 1/10 of a percent. So I'm going to say 0.826086. Okay, so let me write that down. So this is equal to 0.82608, something like that. And if I need to the nearest 1/10% and I move it 2 to the right, I have 82.6%. That should be your answer. Okay. And then it says, the principal would like to make a basic interpretation of these results. Explain what the probability means. Well, it means there's an 82.6% probability that a senior takes AP Physics given that they're in the Key Club. Or 82.6% of all Key Club members are also in AP Physics. But I'm gonna write it how we know it, which means I would say there is an 82.6% probability that a senior, I'm going to say senior, takes AP Physics given they are in Key Club. I think you could also say 82.6% of all Key Club members are also in AP Physics. But that should be perfect. Okay, that's what we're interpreting. Okay, let's look at example 4. So in example 4, we're talking about, which is interesting, kind of like what we're going through right now, the effectiveness of 2 new drugs. So half of the volunteers were, okay, that's a key word. Half of the volunteers were randomly assigned to receive a drug. The other half received a sugar pill. Okay, so almost like a placebo. The probability of a volunteer receiving a drug and getting well, okay, receiving the drug and getting well is 40%. The probability of a volunteer receiving a sugar pill and getting well was 5%. If a person from the study is selected at random, okay, so here we go. What is the probability of a volunteer getting well, given the volunteer received the drug? Okay, so here's what I'm feeling. The probability of getting well, given they got the drug. Okay, so let's just talk about this. What was the probability that they got the drug? Well, half of the people got the drug. So I would say 0.50 or 0.5. Okay, so what's the probability that they got the drug? Well, I would say they got the drug and they were well. Because let's talk about this. If I were going to write out what I'm trying to figure out, well, given the drug, that's the probability of being well and having the drug over the probability of getting the drug. Okay, that's what I need. So what's the probability of well and given the drug? Well and got the drug. That's right here. Received the drug and got well. 40%. 0.40. So that would be 0.40 divided by 0.50, or 0.4 divided by 0.5, which is 0.8. Right? Let me just double check myself. 0.4 divided by 0.5, yep, is my 0.8. Okay, so I'm going back here, 0.8, which is 80%. So I guess it doesn't matter. You could either use 0.8 or 80%. You could use a fraction as well, because they just said the probability. So as long as they're saying basic probability, didn't say percentage, you could leave your answer as a fraction, a decimal, a percent. Okay, the next one, it says, what is the probability of a volunteer getting well given the volunteer did not receive the drug? All right, so now we need the probability of getting well given they didn't get the drug. No drug. Okay, so that means the probability of well and no drug over the probability that they didn't get the drug, no drug. Okay, so what's the probability that they were well? Okay, so here's what we need, the two things we need. The probability that they were well and they had no drug. Here. They were well and they didn't get the drug. So that's the sugar pill and they got well. That's 5%, 0.05. 0.05. What's the probability that they didn't get a drug? Well, the probability that they got no drug is 0.5 because half the people got the drug, the other people didn't get the drug. So that would be 0.50. So 0.05 divided by 0.50 should be 0.10. So let me again just double check myself. That's 0.05 divided by 0.5. Yep, that's my 0.1. Okay, so that's 0.10. You could say 10%. Either one is perfect. Lastly, it just asks, does it seem like the drug is effective? Explain your answer. Okay, well, 80% of people got the drug and were well, and 10% of the people didn't get the drug and were well. So yes, I would say yes, this was effective. Yes. There was an 80%. There is an 80% probability. Probability of getting well given the drug opposed to 10% probability of getting well without the drug. Everybody okay with that? I like this. Okay, so I'm up to the homework, so I'm gonna leave you guys 1 to 4 as your homework. And let me know, do you feel like I'm going too fast? Do you feel like I'm going too slow? I mean, I'm staying in pace for what we would have done in class, 1 lesson a day. I don't know if you're feeling overwhelmed. I've been wanting to just reach out, and I think I'm going to do that just to find out if you feel like you guys are overwhelmed with work. So let me know if you are listening to my videos. Send me a private message and let me know if you're feeling a little bit overwhelmed, if you want me to slow down, pick up the pace, or stay on track. Okay, I hope everybody's well. I miss you all so much.